All right. So in this case, we're going to try to calculate the total strain energy in for simple loadings. So in this case, we're going to talk about if you had a rod that you had applied a normal force to it. It can be either in tension or compression. So if we assume tension, all right, and we took a small element out of our rod, all right, that small element would have a stress within the x direction, sigma x. Okay, so we can say that the total strain energy in the axial direction would be equal to the strain energy, the integral of the strain energy over that volume element. Okay, so we can plug in from earlier in the lecture. We know that the strain energy in the x direction would be equal to 1 over the elastic modulus times sigma x squared. Okay, so we can then plug in for sigma x for an axial stress. We know that sigma x is just equal to the force over the area. So we can then, and then we know that the volume element, dV, here is just equal to whatever the area is on top times dx. Right? That area would be sorry. This is the volume element. My apologies. Here, this is dV. All right, where we have a constant area. All right, and then the distance, differential distance is dx. Okay, so if we plug in our terms here, we end up getting this equation for our integral for the total strain energy in the axial direction. So if the force is constant, the elastic modulus is constant, meaning the same material, and the cross-sectional area constant along the beam, this integral becomes really simple. All these terms are constant; they can come out of the integral, and we just have the integral of dx, which is just going to be equal to x. So if we evaluate that across the whole length of the beam, what we end up getting is our total axial stress would be equal to this. And just for comparison, we can say if we want to just find the total work done on the bar, we know that the work on a system is equal to the force applied times the displacement times 1/2. So if we plug in 1/2 and we plug in our force applied, we know the displacement of an axial rod from strength of materials is the force times the length divided by EA. So we end up getting the same values for these two equations. So that's good because we know that the strain energy in an elastic system should be equal to the work done on the bar. All right.